All right, y'all. So this is new unit. So number 7, chapter 7, and today we're going to talk about absolute value functions. And so we know what an absolute value is. Absolute value is denoted by these symbols right here, and the absolute value is going to be the distance from 0. So if I have this value in here, the distance from 0, if I look at this on a number line, is just 3. If I look at this number, -3, the distance on the number line is still going to be a 3. So a lot of times people say, oh, you just take the value that's on the inside and you make it positive. And really what we're doing is we are not just making this positive, we have to make it whatever is true on the inside. So here's why. If we have this value where we have some value of x equals 5, then we know x is going to be positive 5, and x could be negative 5. So it could be this value or this value. So because here we don't know what the x term is, we have to have a positive and a negative value. So to solve this, we're going to do a couple things. The same thing that we've done with every other function. We're going to isolate the absolute value bars. That's going to be the first thing that we want to do. And then once we isolate the absolute value bars, then we're going to write two equations. And I'm going to have one that's positive, and I'm going to have one that's negative. And then we're going to solve for x. So these are the steps that we're going to take when we solve an absolute value function. And so what this says is when solving absolute value functions, you should always write two equations. That's what it comes down to. So you might have two answers for these. All right, so let's try this. Here's what it looks like. This is isolated. All I have over here is the absolute value bars. So because of that, I'm going to have one that's positive and one that's negative. So at this point, I can eliminate my absolute value bars, and I have x minus 5 equals 7, which means I didn't change anything. I just made this a 7. On this side, I have x minus 5 equals negative 7. I took this value and I made it negative. Now, we'll get back to what happens if this is negative here in a second, but what I want you to notice is nothing changed. This sign on the inside didn't change, nothing changed. The only thing that changed was on the other side of the equal sign. That's why we have to isolate it. And then we just solve this. So I add 5 to both sides, and I have x equals 12. And over here, I'm going to add 5 to this side, so I get x equals negative 2. And these are my two answers. Now, I can plug it back in and check it. And here's what I have. 12 minus 5 in the absolute value bars. And if I solve this, I get 7. So that's correct. And then over here, I have negative 2 minus 5. Well, I have a negative going more negative. So the answer here is absolute value of negative 7. And we said that when we have a number that's on the inside, we can make this a positive number, which is what we have up here. So you can always go back and check your answers and make sure that you did the algebra right. Okay, now this one I cannot automatically go and do positive and negative because it's not isolated. I have to move this 5 first. Okay, so to do that, I divide both sides by 5. So I get 5x minus 10 equals 9. And I'm going to write a note over here. We will never distribute into the absolute value bars. You're never going to distribute into the absolute value bars. So you cannot say 25x minus 50. You have to move whatever's on the outside first. So now I have my two sides here. So I have 5x minus 10 equals 9, and 5x minus 10 equals negative 9. So now I'm going to add 10 to both sides, and I have 5x is 19. So x equals 19 over 5. It is okay to have a fraction. It's okay to have a fraction. So now I go the other way. So I have 5x is going to equal 1 because I'm going to add 10. So I have negative 9 plus 10. So x is going to be 1/5. Okay. Let's look at this one. So this is on the outside. Up here, this was not isolated. I had to divide by 5. This is not isolated. I have to subtract by 2. So my isolated equation is 3x minus 2, and this is going to equal 13. Okay, so now I have a positive and I have a negative. All right, so I didn't talk through that. At this point, I know you can solve a linear function because that's what this is. This is a line. All right, now let's talk about this guy because this one's different. And this is so different that I'm going to highlight it. So what happens here is this is already isolated. So what we want to say is, okay, we separate this into a positive and a negative, but that is not true in this case. And that is because of this value right here. So if I look at this and I say, okay, if I've got a number inside the absolute value bars, so let's go back up here to my example, and I have -3, I say that this is +3. If I have a positive number in there, then I would say that this is still 3. So what this is saying is that there is no value that will ever give, no value gives a negative absolute value. So because this is negative right here, there's nothing in here in the absolute value bars that's going to make this a negative. So what we're going to say is that this is no solution. Now, flip it over real quick because I want to give you another example of something. So let's say I had this. 3x plus 1 minus 5 equals -2. So we just said that we can't have anything over here be negative. But look what happens. This is not isolated. So now I have 3x plus 1 equals 3. And so what happens is when I add 5 to both sides, I now have a positive number. So I can solve this. So be careful. Don't just look and say, oh, there's a negative number, so there's no solution, because I have to isolate it first. And when I isolate it, I see I have an answer, and I can go ahead and make at this point my positive and my negative answers. Okay?